students, this is Sivakumar, 10th standard mathematics, chapter number 3, exercise 3.13, nature of roots of a quadratic equation. Listen carefully. The roots of the quadratic equation ax square plus bx plus c equal to 0, a is not equal to 0, are found using the formula, you know very well, x equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. Here, the expression which is inside the square root, what it is, b square minus 4ac, called as the discriminant, which is denoted by delta. What it is called? Delta. Of the quadratic equation decides the nature of the roots as follows. Value of a discriminant, the delta. What is delta? Delta equal b square minus 4ac. If it is positive, that means greater than 0, the nature of roots, real and unequal roots. If delta value is equal to 0, the roots are real and equal. If delta is less than 0, that means negative numbers, no real roots. That means the roots are imaginary. What it is called? Imaginary or unreal. Okay. Now we can get into that exercise. Exercise 3.13. Question number 1, subdivision number 1, 15x squared plus 11x plus 2 equals 0. The question is determine the nature of the roots for the following quadratic equations. Now subdivision number 1. To find the nature, you have to find out delta. Delta formula b squared minus 4ac. What about that ABC right over here? You know very well, in the quadratic equation, a refers coefficient of x squared. What it is? 15. B, that is the coefficient of x, 11, and constant is c. 15, 11, 2. 15, 11 and 2. Substitute here. B, that is equal to 11, 11 square, minus 4 into a into c. A value is 15 and c value is 2. 11 square, that is equal to 121. 11 11s are 121, minus 4 into 15, that is 60. 60 into 2, 120. That is equal to 1. 1 which is positive number greater than 0. Already I told you, if a delta is positive, that is greater than 0, the roots are real and unequal. Subdivision number 1 is over. Now subdivision number 2. X squared minus x minus 1 equals 0. X squared minus x minus 1 equal to 0. Write ABC first. Coefficient of x squared is a, that is 1, and x coefficient is minus 1, that is b. C is minus 1. So 1 minus 1 minus 1. Then find out delta. Delta, you know the formula, b squared minus 4ac. B, that is equal to minus 1, the whole square, minus 4 into a value into c value. A value is 1. C value is also minus 1. Minus 1, the whole square is 1. Minus into minus plus, 4 into 1, 4. Again 4 into 1 is 4 only. 4 plus 1, 5. Again greater than 0. Whenever the positive comes, the roots are real and unequal. You have to write. Now subdivision number 3. Question. Root 2 into t squared minus 3t plus 3 root 2 equals 0. Write a, b and c. Here a is the coefficient of t square, that is root 2. B is the coefficient of t, that is minus 3. And c is the constant term, 3 root 2. Find out delta. Delta formula b squared minus 4ac. b that is equal to minus 3 the whole square minus 4 into a value into c value. A value is root 2, c value is 3 root 2 equals minus 3 the whole square is 9 minus 4 3s are 12 into root 2 into root 2 is 2. 9 12 2s are 24. 9 minus 24 that is equal to minus 15. It's a negative number, so we have to put less than 0. If it is less than 0, you have to write the roots are not real. Very simple. Even you can write unreal. Even you can write the roots are imaginary. Write any one of them. Now subdivision number 4. 9y square minus 6 root 2 into y plus 2 equal to 0. Write ABC. So equation in terms of y. So a is the coefficient of y square, that is 9. B is the coefficient of y minus 6 root 2. And c is the constant term 2. Now find out delta. Delta formula b square minus 4ac. B that is equal to minus 6 root 2 the whole square minus 4 into a value into c value. A value is 9 and c value is 2. Minus 6 the whole square is 36 into root 2 square is 2 minus 4 9s are 36. 36 into 2 that is 72. So 36 2s are 72 minus 72 equals 72 minus 72 equals 0. So if delta value is equal to 0, you can write the nature. The roots are real and equal. Now subdivision number 5. Last subdivision. 9 a square b square x square minus 24 abcd into x plus 16 c square d square is equal to 0. A condition given, a is not equal to 0 and b is not equal to 0. Suppose a and b are 0 means you will be getting no x square term. If no x square term means that is not a quadratic equation. So anyway, you can find out delta. In the question itself we have small a, b, c and all. So that I write that formula for delta is b squared minus 4ac. Look at that, a, b, c are in capital letters. A, b, c. Instead of small a, b, c, I have taken capital A, b, c. Capital A is the coefficient of x square. What is here? 9a squared b squared. And b is the coefficient of x including the sign, that is minus 24 abcd. And c is the constant term 16 c square d square. Substitute b square, b that is minus 24 abcd the whole square minus 4 into a value that is 9a square b square into capital C value 16 c square d square equals minus 24 square, that is equal to 576. I mean 24s are 576. A square b square c square d square. Each and everyone have to square. A square b square c square d square. 4 9s are 36. 36 into 16, that is also 576 minus 576. Again I tell you, 4 9s are 36. 36 into 16 is 576. A square b square c square d square. A square b square c square d square. These two are same, correct? Both get cancelled or getting 0. If delta equals 0, the roots are real and equal. So problem number 1, all the 5 subdivisions are over. I'll be teaching problem number 2 in the next video. Thank you, children. Hi students, this is Sivakumar. 10th standard mathematics, chapter number 3, continuation of exercise 3.13. Find the value or values of k for which the roots of the following equations are real and equal. 2 subdivisions are there. Can do one by one. Write capital A, B and C. You can take small ABC or capital ABC. Capital A is the coefficient of x square, that is 5k minus 6. And B is the coefficient of x, that is 2k. And C is the constant term 1. Since what is given, roots are real and equal. Roots are real and equal. We know the value of delta. Delta is obviously 0. Delta 0 means roots are real and equal. If roots are real and equal, you can write delta as 0, which implies delta, you know the formula, b square minus 4ac, that is equal to 0. The next step, retain b square only in the left hand side, minus 4ac to be taken to the right hand side, you will be getting plus 4ac. Then substitute all the values of a, b and c. b square, that is 2k the whole square. 4 into capital A, that is equal to 5k minus 6 into capital C, that is equal to 1. 2 squared is 4 and k power 2 is k squared equals 4 into 5k minus 6 into 1 is 5k minus 6. Before multiplying these two, you can directly cancel 4 and 4. Then you write k squared plus 5k comes in the next step. You can write k squared, it comes left hand side minus 5k, it comes left hand side plus 6 is equal to 0. It's a quadratic equation. You can solve. 1 into 6 is 6 and the coefficient of k, that is equal to minus 5. Product 6 sum minus 5, the two numbers are minus 3 and minus 2. Add the two numbers minus 5, multiply the two numbers plus 6. Since it is an equation, you can find the values of k directly. To get the values of k directly, consider the coefficient of k squared, what is here 1, change the sign and write in the denominator. That means 1 becomes minus 1, write in the denominator. If it is an equation only, you can write like this. Right, minus get cancelled, here also get cancelled. 3 by 1 is 3, 2 by 1 is 2. So 3 by 1 is 3 and 2 by 1 is 2. That's all. So we have double values of k. Subdivision number 1 is over. Now subdivision number 2. Roots are real and equal. Solution. Since roots are real and equal, delta is equal to 0. Write capital A, B and C. A is the coefficient of x square, that is k only. B is the coefficient of x, that is 6k plus 2. And constant C is 16. You know the formula for delta formula, b squared minus 4ac, that is equal to 0. Retain b square only, minus 4ac comes right hand side plus 4ac. Then b, that is equal to 6k plus 2 the whole square, that is equal to 4 into a value is k and c value is 16. Okay, 6k plus 2 the whole square. You can apply the formula a plus b whole square. I write that identity here. A plus b the whole square identity is a square plus b square plus 2ab. A square plus b square plus 2ab. A, that is 6k, b, that is 2. Here a and b, a that is 6k, b that is 2, equals 4 into 16, 64. 64 into k, 64k. We have to simplify. 6 square is 36 and k power 2 is k square. 2 square is 4. 2 6 are 12, 12 2s are 24k. The 64k comes left hand side minus 64k, nothing in right hand side, you have to put 0. First write 36k square. So like terms, 24k minus 64k, that is equal to minus 40k, correct? Plus 4 is the constant at the last, that is equal to 0. Before factorizing, so 36, 40 and 4, all the three numbers in which table we can get? 4 table itself. 2 table as well as 4 table, which one is greater? 4. You can go for 4 table. So divide by 4. Each and every term should be divided by 4. 36 by 4, how many times? 4 9s are 36. 9k squared. 40 by 4, 4 table how many times? 10 times. 4 table, 4 by 4, that is equal to 1, that is equal to 0. Now we can factorize. Okay. The coefficient of k squared equals 9. 9 into 1 is 9. Coefficient of k, that is equal to minus 10. Product 9 and sum minus 10. For getting 9, we have a double combination. 9 ones are 9 and 3 threes are 9. Here you have to take 9 ones are 9 only. For getting minus 10, introduce minus for both the numbers. Add the two numbers, minus 10. Multiply the two numbers, plus 9. To find the values of k directly, since it is an equation, the coefficient of k squared is 9. Change the sign. 9 becomes minus 9. Write in denominator. Minus minus get cancelled. Even 9 get cancelled 1. Here minus minus only get cancelled. So 1 and 1 by 9. 1 and 1 by 9. So k equals 1 and k equals 1 by 9. Here also we have double values for k. So question number 2, both the subdivisions are over. I will be teaching problem number 3 in the next video. Thank you, children. Hi students, this is Sivakumar. 10th Standard Mathematics Chapter number 3, continuation of exercise 3.13. Now problem number 3. If the roots of this equation a minus b into x square plus b minus c into x plus c minus a equals 0 are real and equal, roots are real and equal, then prove that b, a, c are in arithmetic progression. B, A, C are in arithmetic progression. Before doing this problem, I have to explain the concept of arithmetic progression. Listen. If A, B, C are in AP, AP refers arithmetic progression. This is a condition. 2B, that is equal to A plus C. I give an example. What do you mean by arithmetic progression? 1, I have taken one example. 1, 3, 5, 7, 9. It is uniformly increased. That is 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9. It is going on. Generally, numbers separated by comma, that is called sequence. What it is called? Sequence. At the same time, the difference between second number and third number, second number and first number, and third number and second number, difference are same. For example, 3 minus 1 equals 2, 5 minus 3 also 2. We can say that is an arithmetic progression. Okay, even you can consider 3, 5, 7. 5 minus 3 equal to 2, 7 minus 5, that is equal to 2. Right. For ABC, 3 consecutive numbers ABC, you can take 135 or 357 or 579. I have taken 3 as A, 5 as B and 7 as C. What is the condition? 2B, that is equal to A plus C. First I am finding the value of 2B. 2B. 2 into B values, what I have taken? 5, 2 5s are 10. Then what is the right hand side? A plus C. A I have taken 3 and C I have taken 7. 3 plus 7 also 10. 10 and 10. So 2B, that is equal to A plus C. Even if we consider 5, 7 and 9, A, B, C, since it is B, 2 7s are 14. 5 plus 9 also 14. Okay. Therefore, 2B equals A plus. This is a condition if A, B, C are in arithmetic progression. Okay. Now, the given equation, you are given the roots are real and equal. We have to prove BAC are in AP, not ABC. BAC are in AP. If ABC are in AP, which is at the middle, B, so 2B equals first plus last, A plus C. Here, which is at the middle, A, so 2A equals first plus last, B plus C. So what we have to prove? 2a that is equal to b plus c. So listen carefully. Since roots are real and equal, delta equals 0. You know the formula for delta. Delta, that is b squared minus 4ac equal to 0. Retain b squared minus 4ac comes right hand side plus 4ac. Right? Capital A, capital B, capital C. Coefficient of x squared, coefficient of x and constant. What is the coefficient of x squared? A minus b. This is capital A, capital B, capital C. A minus b, b minus c, c minus c. A minus b, b minus c, c minus c. B square, that is b minus c the whole square equals 4 into a into c. Capital A is a minus b, capital C is c minus c. Here you can apply the formula a minus b whole square. You can apply the formula a minus b whole square, that is a square, b square plus c square minus 2bc, because we know that what is the identity a minus b whole square? A square plus b square minus 2ab. Okay. Instead of a and b we have b and c. So b square plus c square minus 2bc according to this identity. That is equal to 4 into multiply a into c, ac, a into minus a square, minus b into c minus bc, minus b into minus a, that is plus ba or ab. So b squared plus c squared minus 2bc, that is equal to 4 into ac, 4ac minus 4 into a squared minus 4a squared, 4 into minus bc minus 4bc, 4 into ab is 4ab. Now I am taking all the terms on the right hand side to the left hand side. First a squared minus 4a squared comes left hand side plus 4a squared. Then b squared in the left hand side only as it is. Then c squared left hand side only as it is. Then combination of a and b. Here only we have the combination of a and b. 4ab comes left hand side minus 4ab. Then combination of b and c. B and c, here it is. Here also we have bc, right? Minus 2bc as it is. This minus 4bc comes left hand side plus 4bc. Finally the combination of c and d. C and d or a and c. What is here? 4ac. 4ac comes left hand side minus 4ac, that is equal to 0 because nothing in the right hand side, so you have to put 0 in the right hand side. Now 4a squared plus b squared plus c squared as it is, minus 4ab as it is, the like terms only because bc like terms. 4bc minus 2bc equal to 2bc minus 4ac equal to 0. How many terms we have? 1 2 3 4 5 6. Out of 6 terms, first 3 terms are perfect square numbers. If it is, it can be written bracket square, again bracket square, again bracket square, then plus 2 bracket bracket, plus 2 bracket bracket, plus 2 bracket bracket equals 0. So that means this is of the form a square plus b square plus c square 2ab, 2bc, 2ca. Now 4a squared is there. So can we write 2a the whole square? 2 squared is 4, a squared is here. B squared you can write b squared. C squared you can write c squared. Now, so here a, b, instead of a what is here? 2a. B, b only. Here b and c. Here b and c only, no change at all. Then c and a. C write as it is. Instead of a what is here? 2a. We can verify now. 2 into 2a into b, 4ab, but we have minus 4ab. So 1 has to be given minus. Generally can get minus ab. But the first term cannot be negative. So what is the first term? 2a. So that we have to introduce minus for b. Since I have introduced minus for b, wherever b comes that should be replaced by minus. Here b, that should be replaced by minus. Here b, that should be replaced by minus. Now we can verify now. Plus into minus, minus, 2 2s are 4, 4, a into b, ab. Correct. Now plus into minus, minus 2bc, but we have plus 2bc. For getting plus 2bc, the c has to be introduced minus. Wherever c comes, that should be replaced by minus. Here c minus, here c minus, here c minus. Now we can verify. 2a the whole square is 4a square, minus b square also b square, minus c the whole square is c square, plus into minus, minus 2 2s are 4 into a into b, 4ab, plus into minus, minus, minus into minus, plus 2 into b into c, 2bc, plus into minus, minus 2 2s are 4, 4 into a into c, 4ac. Everything is perfect. Now write the identity. We know that a square plus b square plus c square plus 2ab plus 2bc plus 2ca, that is equal to a plus b plus c the whole square. It's identity. Here what is a, b and c? Instead of a we have 2a, instead of b we have minus b, instead of c we have minus c. So 2a minus b minus c, 2a minus b and minus c, that is equal to, listen, formula, sorry I put implies not equal to, implies. Here is the formula, a plus b plus c the whole square, correct? A plus b plus c the whole square equals, what is in the right hand side? 0. Listen carefully. A has to be replaced by 2a, b has to be replaced by minus b, and c has to be replaced by minus c. Okay, whole square is equal to 0 is equal to 0. Now for eliminating the square root, taking square root on both sides, so square root of 2a minus b minus c the whole square equal to square root of 0. Already told you, whenever the square comes, for eliminating square you have to introduce plus or minus. Now square and square root get cancelled. You write 2a minus b minus c, that is equal to plus or minus 0. Plus or minus 0, 0 only, you just write. I am retaining 2a only in the left hand side, and minus b comes right hand side plus b, minus c comes right hand side plus c. Already told you, if 2a equal to b plus c, since 2a is there, write a at the middle. What are the two numbers, what are the two variables in the right hand side? B and c. B first, c last. BAC or NAP. We have proved BAC or NAP. Okay, that's all. Now problem number 3 is over. Very important problem. This question may be asked in 5 marks. Practice well. I'll be teaching problem number 4 in the next video. Thank you, children. Hi students, this is Sivakumar. 10th standard mathematics, chapter number 3, continuation of exercise 3.13. Now problem number 4. If a and b are real, then show that the roots of the given equation are real and unequal. Solution. Compare the general equation, compare the given equation with the general equation of the quadratic equation. That is ax square plus bx plus c, that is equal to 0. You write capital A, capital B and capital C. A is the coefficient of x square, that is small a minus b, and b is the coefficient of x including the sign minus 6 of a plus b, and capital C is the constant, that is minus 9 of a minus b. For proving the roots are real and unequal, it is enough to find delta, that is equal to b squared minus 4ac. b here it is minus 6 into a plus b, the whole square, minus 4 into a value is a minus b and capital C value is minus 9 into a minus b. That is equal to minus 6 the whole square is 36 and a plus b whole square. Minus into minus plus, 4 9s are 36, A minus b into a minus b is a minus b the whole square. Between these two you can take 36 as common. If you take 36 common, you'll be getting here a plus b the whole square, here a minus b the whole square. That is equal to 36 into, you know the formula for a plus b whole square, a square plus b square plus 2ab. And a minus b whole square formula, a square plus b square minus 2ab. Plus 2ab minus 2ab get cancelled. 36 into a square plus a square, that is 2a square, b square plus b square, that is equal to 2b square. 36 into, from these two we can take 2 as common. If we take 2 as common, so a square will be there plus b square will be there. 36 2s are 72. 72 into a square plus b square, that is delta. 72, it is a positive number. A square, look at the square. Since the power is an even, definitely it is a square, it is a even number, positive number. And b square, since square is in the power, that is also positive. Positive plus positive, positive. Positive into positive is positive. So you can write greater than 0. Greater than 0 means positive. Positive means you know that the roots are real and unequal. Therefore, the roots of the given equation are real and unequal. Problem number 4 is completed. I will be teaching the next problem in the next video. Thank you, children. Students, this is Sivakumar, 10th standard mathematics, chapter number 3, continuation of exercise 3.13, last problem. The roots of the equation are real and equal. Then prove that either a equals 0 or a cube plus b cube plus c cube, that is equal to 3abc. Okay. Proof. Write that capital A, capital B and capital C. Capital A, why we are considering capital ABC and all, the given equation itself we have small abc, so that you can consider capital A, capital B and capital C. Capital A is the coefficient of x square, that is c square minus ab, small c square minus ab. And capital B is the coefficient of x including the sign minus 2 of a square minus bc. And capital C is the constant b square minus ac. Given roots are real and equal. Roots are real and equal. We know that if the roots are real and equal, the value of delta equals 0. The delta can be replaced by b square minus 4ac, that is equal to 0. Which implies b, here it is b, that is equal to minus 2 into a square minus bc whole square minus 4 into a, capital A values c square minus ab into capital C values b square minus ac, that is equal to 0. We have to simplify. Minus 2 the whole square, that is equal to 4 into a square minus bc the whole square minus 4, let it be. Then had to multiply c square into b square is c square b square or b square c square. Then multiply these two, c square minus ac is minus ac cube minus ac, because c square into c is c cube, minus ab cube, b into b square is b cube, minus into minus plus a into a square, b into c, bc. So a square bc, that is equal to 0. Here 4, here also we have 4. So what is in the right hand side? 0. First we can eliminate 4. Divide by 4. 4 get cancelled, be getting a square minus bc the whole square. Here also 4 get cancelled. We will be getting b square minus c square minus ac cube and a minus ab cube plus a square bc, that is equal to 0. Now, you know the formula a minus b the whole square. A minus b whole squared, that is a square plus b square minus 2ab, correct? So it should be considered as a. Instead of a, what is here? A square. Instead of b we have bc, and here a square, here bc. Okay, we know that. For your reference, I write the formula. A minus b the whole square equals a square plus b square minus 2ab. It's the formula. Here this is a and this one is b. So a square the whole square, bc the whole square minus 2 into a square into bc. Then you multiply by minus b squared c square minus into minus plus ac cube minus into minus plus ab cube minus into plus minus a squared bc, that is equal to 0. A square the whole square is a power 4 plus bc the whole square is b squared c squared minus 2 into a squared bc minus 2a squared bc. Then rest of them as it is. Minus b squared c squared plus ac cube. AC cube plus ab cube minus a squared bc. That is equal to 0. Okay. Now, okay, 2a squared bc here minus a squared bc together. Before that, we can cancel these two. Plus b squared c squared minus b squared c squared get cancelled. Here a power 4. Then you write plus a b cube. Then you write a c cube. These three over. Then left out these two only. So together we will be writing, because I like terms only, a squared bc family, minus 2 times minus 1 time minus 3 times a squared bc, that is equal to 0. Here a power 4 a b cube a c cube minus 3 a squared bc. Here a is the least one, correct? Take a as common. If you take a as common, here a cube will be there, because a into a cube is a power 4. Since I have taken a as common, we will be writing b cube. Since I have taken a as common, only c cube. Since I have taken one a is common, one more a will be there, 3 and bc will be there. You can write 3abc. That is equal to 0. So product of these two equals 0 means either a equal to 0 or a cube plus b cube plus c cube minus 3abc equal to 0. Which implies a cube plus b cube plus c cube, that is equal to minus 3abc comes right hand side plus 3abc. We have proved. What is given? A equal to 0 or a cube plus b cube plus c cube, that is equal to 3abc. Here it is. Okay, proved. Problem number 5 is completed. So exercise over. I will be teaching the next exercise in the next video. Thank you, children.